Hello, and welcome to this lesson in quantitative reasoning. This is part 2 of 2 videos on kind of the introduction to logic, where we talk about statements and logical connectives. In part 1, we talked about what is the definition of a statement and looked at some examples of things that are and are not statements. It has to have a value of either true or false, clearly. And we also looked at negating statements, particularly statements that involve the words all, some are, none are, things like that. That was the more complicated negation. Now we're going to look at how we can combine some simple statements. So in the first part, every statement we looked at had one idea in it. It was a simple statement. In English language and other languages, we hardly ever in communication just have a simple statement. We often have statements that are combined in some way using what we call connectives. So early to bed and early to rise makes a man healthy, wealthy, and wise is an old saying. You may have heard that before. It's kind of a cliche, but we can break this down into simpler statements. Actually, this is packed. This looks like one statement, but it's not. It's actually 5 simple statements put together. So the first idea is a man goes to bed early. The next one is a man rises early. So, they're talking about a man here. So we get that from there. Goes early to bed, early to rise. There's our first 2 statements. A man is healthy. So we're still talking about, and when we say healthy, wealthy, and wise, we mean and healthy and wealthy and wise. So a man is healthy, a man is wealthy, a man is wise. Those are the 5 statements involved in this single sentence. So just because you have a single sentence in English does not mean you have a single statement. You have what we call a compound statement here. It has this one actually has 5 ideas in it. So each one of these that we've broken out over here is a simple statement. We use connectives to combine 2 or more statements into a compound statement. Now, the connectives aren't really clear here because some of them are implied. It turns out this is like saying, if a man goes early to bed and a man is early to rise, then a man will be healthy and a man will be wealthy and a man will be wise. That is really what it's being said here. So what we'll see as we go further on in this unit is we would identify these statements with letters, so we don't have to write all this out all the time. We would say maybe this is statement P, and this is statement Q, this is statement R, this is statement S, and this is statement T. And then we'll have symbols for the words and, or, if, then, if and only if, not. Those will be the 5 sets of symbols we use, the 4 connectives, and, or, if, then, and if and only if, and the negation, not. So then we will be able to write more complicated compound statements using symbols. But you have to be able to break down the language into simple statements before you can translate them into symbols, and that's what we're going to be looking at today. So this is what I just said. Here are we use connectives. I guess not as a connective. The if and only if is a connect. Not is a negation. It's applied generally to one statement. If it's applied to multiple statements at the same time, they are in parentheses with another connective between them. But it is considered to be connective, even though it does act on a single statement in the context of this text. So the negation of a simple statement is a compound statement because it involves a connective. So a simple statement is a statement that conveys a single idea. A logical connective is a symbol or word used to connect 2 or more statements. Here are the words. We're going to see that the symbols are and, or, not, if then. And some books, by the way, use this for the not. I think your book uses this. And if and only if is in both directions. So a compound statement can be written with symbols and with statement letters in one of these symbols, or more than one of these symbols. Here is the summary of what I just wrote. You really should memorize these. Okay, your book uses the 2 arrow, so I wrote this on the if then, but your book actually puts 2 lines on it. Doesn't make a difference. If you see a single arrow, if you see this, it means biconditional. If you see this, it means conditional. Your book will use the 2 lines connecting them. You may see some of the notes I give you that I have from other places will use these single arrows. It means the same thing. These 5 symbols you really need to have memorized. Otherwise, everything will take way too long in this unit. You really need to memorize this. It'd be helpful to memorize it when doing the homework. The first time when you start the homework, have maybe this slide or the table I provided in front of you. And then as you go further and further through the problems, you should be not needing to look at it as much. That's how I would memorize it, by practice. So, determine whether the following is a simple statement, a compound statement, or neither. If it's a compound statement, identify any connectives. Now, this is tricky. This is a math statement. When you see a math inequality, it's probably been a while since you've seen one of these compound inequalities. It is called a compound inequality because there's 2 inequality symbols in it. And it means there's an and. So this is saying 10 is less than 7. Now, this below translates it a little differently. And, this implies an and when you write as one statement here. 7 is less than or equal to 5. Equal to 5. So, there is an and there. Whenever you see this in a math inequality, when it's all written as 1, and more times you see it like -2 less than x less than or equal to 3, like that's your solution set. It means x meets both of these criteria at the same time. It's x is, as you can see, bigger than -2, or -2 is less than x. Those mean the same thing. And at the same time, x is less than or equal to 3. So, 5 is bigger than -2, but that wouldn't be a value for x because 5 is not less than or equal to 3. Both have to be met at the same time. Now, this statement you're given here is false, because right away you see 10 is not less than 7, and 7 is not less than or equal to 5. So, the text reading of this reads it with the greater than. 7 is greater than. Remember that the bigger side of the symbol is the greater than, the point you point to the less than. I like to read this as 10 less than 7, I like to read it left to right. But here's another way you could have translated this. This statement can be true or false. In this case, each of those simple statements is false, even if one of them were true. If this had been a 4 is less than 7, and 7 is less than 5, it would still be false because all of these things have to be true together when you use an and. So, give the formal name of the connective, I think is what we're looking for, and write the sentence symbolically. So you're going to break these up into the simple statements that make them up. So if Jack went up the hill, then Jill also went up the hill. So Jack went up the hill could be statement P. And I'm going to just abbreviate this, went uphill. And Q could be, and we tend to use P and Q in logic. We tend to start there with those letters of the alphabet. It could be A, B, it doesn't really matter. And Q is Jill went up the hill. So I see this word if. We don't always write the then, but we did here. If Jack went up the hill, Jill also went up the hill. We might say without saying the then. But this is an if-then, and if-then is a conditional. We call that a conditional. So we would write it like this. P is Jack is going up the hill. Q is Jill. P is Jack went up the hill. Q is Jill went up the hill. We join them with the if-then with the arrow. We don't this P, and it might be written with a single arrow, is the same as saying statement 1. After we identify our simple statements like this. So Jack and Jill went up the hill. The connective is the and. That will be P and Q. Jack went up the hill but never came back down. We don't have a statement for never came back down. The word but, the key here is always interpreted as an and. So Jack went up the hill, and statement R could be Jack did not come back down the hill. You would do P and R. Let's see how they handle that in the next slide. Okay, we can't use We can use P for Jack went up the hill again, but we can't use Q again because we said that was Jill went up the hill. So we say R never came back down. This should be P and R, not P or R. I don't know why they said P or R. It should be a conjunction, the and statement. Whenever you see the word but, it should be an and. All right, thank you for joining me. And this is the end of this video. Look for more videos in this unit coming up, and see you in class.